Good day everyone. Today we're going to solve another supplementary problems in chapter 3, Total Hydrostatic Force on Surfaces, from the book of 𝙎𝙪𝙥𝙂. So here we have problem 3-102. An open vat holding oil with a specific gravity of 0.80 is 8 meter long and 4 meter deep and has a trapezoidal cross section 3 meter wide at the bottom and 5 meter wide at the top. Determine the weight of the oil and the force on the bottom of the vat and the force on the trapezoidal end panel. So first, let's identify our given. So as stated here, we have the specific gravity of oil, which is equals to 0.80, a length of 8 meter, a height of 4 meter, and a trapezoidal cross section which is 3 meter wide at the bottom and 5 meter at the top. So since we are looking for the weight and the force, we're going to use the formula of specific weight is equals to weight over volume, and for the force is specific weight times height times area. So since the formula for the area of a trapezoid is A plus B all over 2 times height. Let's calculate first the weight of the oil. By using the formula of specific weight is equals to weight over volume. Since volume is unknown, let's solve first the area of the trapezoid, which is equals to A plus B all over 2 times height. Given this illustration, 3 meter wide at the bottom is our base, so set as B. 5 meter wide at the top is our A, and 4 meter deep is the height of the trapezoid. Substituting this given to our formula, area is equals to 3 meter plus 5 meter all over 2 times the height, which is equals to 4 meter. So area is equals to 16 meters squared. To solve for the volume, since volume is equals to length times width times height, and width times height is equals to our area, since this one is our width multiplied to height. So volume is equals to area times length. Substituting the given, so volume is equals to 16 meters squared times 8 meter is equals to 128 meter cube. Back to the equation or formula of specific weight, which is equals to weight over volume, and to solve for the weight, multiply both sides by volume. So weight is equals to specific weight times volume. Since specific weight is equals to density times gravity, and to solve for the density, let's derive the formula of specific gravity, which is equals to density of fluid all over density of liquid. We come up to this equation, specific gravity times density of liquid. Substituting the given, weight is equals to 0.80 times 1000 kilogram meter cube times 9.81 meter per second squared times the volume of 128 meter cube. So weight is equals to 1,004,544 Newton. Converting it to kilonewton, weight is equals to 1004.54 kilonewton. Now let's proceed in solving the force on the bottom of the vat by using the formula of force is equals to specific weight times height times area, and this equation was derived from the equation of pressure. So since all the given is known, let's equate it to the formula of force. So force is equals to 0.80 times 1000 kilogram meter cube times 9.81 meter per second squared times the height of 4 meter times the area of 3 meter wide and 8 meter long. So the force on the bottom of the vat is 753,408 Newton. Converting to kilonewton, force is equals to 753.41 kilonewton. So let's proceed in solving the force on the trapezoidal end panel. For the force on the trapezoidal end panel, let's set G as the depth of the centroid, which is found here. Since the formula of the depth of the centroid, which is equals to A plus 2B all over A plus B times height over 3. since I have said earlier that 5 meter is our A, 3 meter is our B. So let's substitute it to the formula. So G is equals to 5 plus 2 times 3 meter all over 5 meter plus 3 meter times the height of 4 meter all over 3. So the depth of the centroid is 1.8333 meter. To solve for the force, we're going to use the formula of force is equals to specific weight times height times area. Since all the given is known, let's equate it to the equation of the force. So force is equals to 0.80 times 1000 kg per meter cube times the gravity of 9.81 meter per second squared times the height of 1.8333 meter times the area, which is equals to 16 meters squared. So the force on the trapezoidal end panel is 230,208 Newton. Converting to kilonewton, force is equals to 230.21 kilonewton.